Now, we have the concepts of methods of design. So far, we have seen what do you mean by concrete, what is mean by reinforced cement concrete, what are the reasons for using steel as a only material in the case of reinforced cement concrete structures, what is water cement ratio, and how to calculate amount of water for the particular batch of cement. Then what do you mean by grades of concrete and grades of steel. In the case of grades of concrete, we have seen what do you mean by M, what the numerals refers to. So, here the numerals are refers to characteristic strength of materials. The characteristics as per IS 456 they defined like characteristic strength of materials is strength of materials below which not more than 5% of the test stresses are expected to fail. Then we have also seen why they have allowed certain percentage of the test results may be expected to fail. This is only due to there is the variation in the strength of materials and the load on the structures. Now, we move on to the concepts of methods of design. There are three different methods which are used to design the structure. They get predicted. One is working stress design method, second one is ultimate load design method, third one is limit state design method. Before that, so here we are going to have the working stress method. Before that, what do you mean by stress? How to explain the stress? Is a stress when the material is subjected to any kind of forces is that force which try to change the shape of the materials. We all know that the material which consists of many number of molecules or particles. So, the particles or molecule which constitute the material or the body which tries to resist the change in the shape of the body. So, as the resistance increases, the deformation increases. When the full resistance to the external force is set up, the deformation stops, or if the body is not able to develop any resistance to the external force, the deformation goes on continuing up to the failure. So, the resistance to the deformation per unit area of the body is called as stress, and the corresponding deformation, that is the change in deformation per unit length of the body, is called as strain. Now, here we have seen working stress. We have seen what do you mean by the stress. Stress is when an external system of forces which is acting on the body, it is trying to change the shape of the body. The particles or molecule which constitute the body resist the change in the shape of the body. So, the resistance increases, the deformation increases. When the resistance to the external force is set up, the deformation stops. If the body is not able to develop the full resistance to the external force, the deformation goes on continuing up to the failure. So, the resistance per unit area of the body is called as a stress, and the corresponding deformation per unit length of the body is called as the strain. Now, we come to what do you mean by working stress. Before that, what do you mean by ultimate stress? Before that, what do you mean by ultimate load? The load at which the material can sustain before breaking is called as ultimate load, and the corresponding stress is called as ultimate stress. But in practice, the material or any structure which is not subjected to ultimate stress, when it reaches the ultimate load or stress, it starts failure. So, the actual value of the stress is kept much less than the ultimate load, and it is always well within the elastic limit. So, the maximum value of the load to which the material can be actually subjected is known as working load, and the corresponding stress is called as working stress. So, here there is a difference between what do you mean by working load and ultimate load, and working stress and ultimate stress. So, ultimate load means the load at which the material can sustain before breaking, and the corresponding stress is called the ultimate stress. Normally, in practice, the materials or any structure which are not subjected to ultimate load, the actual value of load is kept much less than the maximum value of the load, that is much less than the ultimate load, and it always should be well within the elastic limit. So, the actual value of the load or the maximum value of the load to which the material can be actually subjected is known as working load, and the corresponding stress here it is called as working stress. So, here I have told that there is an elastic limit. What do you mean by elastic limit? Before that, what is mean by elasticity? The property of the material to return back to its original position after the removal of external force is called as elasticity. On the removal of external forces, the stress can completely disappear, but the deformation need not fully disappear. So, the limiting value of the load that can be found up to within which the deformation can completely disappear on the unloading. So, the load corresponding to that limiting value of the load is called as elastic limit. So, here this method which is mainly talk about the material which are subjected within the elastic limit, and is talk about the elasticity property of the elasticity, or this material which is normally up to the elastic limit. This method is otherwise called as elastic design method. This method is always called as elastic method due to the material which are subjected only up to its elastic limit. So, they consider the materials are only up to their elasticity. So, here another one mechanics they have used here, it is called as modular ratio. The modular ratio which is normally denoted by m equal to 280 by 3 sigma CBC. This is another well known mechanics here they have used. Now, here when we talk about the ultimate stress and the working stress method, when we go about the ratio, that is ultimate stress divided by working stress, that is called as factor of safety. We all know that. So, what about the factor of safety they have used in the case of working stress method? For example, in the case of concrete, the concretes are graded like M20, M25, M30, M35, something like that. We can also take M15. The working stress of the M15 grade concrete is 5, and the ultimate stress of the M15 grade concrete is 15. For M15, M refers to the mix, 15 refers to characteristic compressive strength of concrete, or otherwise called as is may be the ultimate stress. When you have the factor of safety, that is 15 divided by 5, that is equal to 3. So, here they have used 3 as the factor of safety for concrete. In similar manner, M20 grade concrete, as per IS code, the working stress here it is 7, and for M25 it is 8.5. So, when you have here, and for M30 grade concrete it is 10. Here the ultimate stress of M20 grade concrete is 20, and here it is 25, here it is 30. So, when you have 20 divided by 7, or 25 divided by 8.5, or 30 divided by 10, that may be nearly equal to 3. So, they have used huge amount of factor of safety for concrete, that is 3. In the case of steel, there are 3 grades of steel, that is mild steel, another one is Fe 415, Fe 500. The working stress of mild steel here it is 140 Newton per millimeter square. For Fe 415 it is 230, and here I think it is 275, and here ultimate stress of mild steel grade concrete is 250 Newton per millimeter square. Ultimate stress of Fe 415 is 450 Newton per millimeter square. For 500 it is 500. So, when you have the factor of safety 250 divided by 140, it may be 1.8, and 415 divided by 230, here it may be 1.8, 500 divided by 275, it may be 1.8. So, here they used again huge amount of factor of safety for steel. So, that is why this method is not economical when compared to the other two method. So, they have used huge amount of factor of safety, that is 3 for concrete and 1.8 for steel. Due to that, here this method which is normally failed to give the maximum load on the structure, serviceability and exact economy in design and idea of reserve strength of member. And also the actual stresses developed in the structure at the working load, which is completely differed from the theoretical values. This is a second reason for the failure of this working stress method. And here the reason behind is the assumption that concrete is assumed as an elastic material. Perfectly it is not correct. On the contrary, it is more complex material. So, this is something an introduction about the working stress method. Then they found the ultimate load design method. In the case of ultimate load design method, but in the case of working stress method, they have taken concrete as a plastic material, but here they have considered inelastic and plastic behavior of concrete and steel. And here the loads are normally multiplied by the factor of safety to arrive the ultimate load, and also the ultimate stresses developed in the concrete and steel are known real values. Anyway, that however, the deflection and cracking effects were not considered under working loads, working conditions in the case of working, that is ultimate load design method. So, this method is only used to check the ultimate load on the structure after designing with the help of working stress method to give the idea of real factor of safety of the structure. So, this is about ultimate load design method.